Hello everyone, in this video we will be covering how to graph parabolas. So how to graph a function that has the equation y is equal to ax squared plus bx plus c. To do this we are going to be using completing the square and factorization of quadratics. We will not be using derivatives at this point, because you can draw these functions well before you learn about derivatives. So firstly, let's look at what information we can extract from this equation before we even mess with it. So we have the equation y is equal to ax squared plus bx plus c. So what can this a over here tell me about the equation? So the sign of a can actually tell us the shape of our parabola. So if we have a positive a value, we'll end up with a parabola like this, and if we have a negative a value, we'll end up with a parabola like this. So we can see if we have a positive value, we have a happy parabola, and if we have a negative value, we have a sad parabola. And that's an easy way to remember it. So the sign of our a value tells us whether our parabola goes from decreasing to increasing or from increasing to decreasing. Now, the size of the a value can also tell us something about the parabola. So if we have a very large negative number, or we have a very large and positive number for a, we'll end up with very skinny graphs. So we'll have these types of graphs which are very close to the y-axis. They're very skinny for positive values of a, and for negative values you'll have them in different directions. Now, consequently, if we have very small numbers, we'll end up with very wide graphs. So if we have very small a values, we'll end up with very wide graphs like this. And that's what the a value can tell us. Now let's look at the b value. Now, what can the b value tell us? The b value can't tell us anything on its own, so we're going to ignore it for now. Let's see what the c value can tell us. Our c value is our y-intercept. So if our c value is positive, we could end up with something like this, where this is my c value. Or if my c value is negative, I might end up with a situation like this, where I have a negative intercept over there. So we already have our y-intercept from our original equation. Now, to graph this parabola, we are going to need to know the y-intercept, which we already have, the x-intercepts, and the turning point. And with this information, we will be able to graph it. So first let's find the x-intercepts. Now to find the x-intercepts of a function, we need to make y 0, and that's how we get our x-intercepts. So from this equation we have 0 is equal to ax squared plus bx plus c. Now how we solve this is we just factorize the quadratics and we'll find our x values. And if it does not factorize very nicely, we can use the quadratic formula to factorize it for us. And this will give me my two x-intercepts. So now we have the y-intercept, we can get the two x-intercepts from here, we already know the shape of the graph. All we have left is to find the turning point. Now to find the turning point of the graph, I am going to complete the square. So when I complete the square, I'll end up with the equation of the form y is equal to a x minus p squared plus q. And how I get my turning point from this equation is that I say what this p value, it's a minus p. So I'm going to put a positive p here. So if this was x plus 4, this would be a minus 4 here as my x coordinate, and q will be my y coordinate, and this is my turning point. So once again, whatever the sign of p is here, we change it to the opposite sign when we find our turning point. And now that we have everything that we need, we will just put it on a graph and join the dots and follow the shape given by A. So let's do an example where you can see all of this in action. Let's consider the function y is equal to x squared plus 2x minus 3. So from this already we can see that we have a 1 in front of the x squared and it is positive. So we are going to have a happy graph. And we know that the y-intercept is minus 3, so we're going to have a y-intercept somewhere down here of minus 3. Now what I need is the turning point and the x-intercepts, and then I will be able to graph it. So first let's find the x-intercepts. So to find the x-intercepts, I make y equal to 0. So I get 0 is equal to x squared plus 2x minus 3. Now to solve this equation, I need to factorize it, and then I will get my solutions. So if you're unfamiliar on how to factorize quadratics, please go watch the factorizing quadratics video. Now factorizing this gives us x plus 3, x minus 1 is equal to 0. And this gives me my two x solutions. So I will get x is equal to minus 3 or x is equal to 1. So that means I have an x-intercept at minus 3 and 0, and I have an x-intercept at 1 and 0. Now all I need is my turning point, and then I will be able to draw this graph. So let's find the turning point. So to find the turning point, I'm going to need to complete the square in this equation. So if you're unfamiliar on how to complete the square, please go watch the completing the square video. So I will do it very quickly here. To complete the square here, I will say 2 divided by 2 squared is 1. So I'll add 1 and subtract 1. So I'll get x squared plus 2x plus 1 minus 3. And now this factorizes to a squared bracket, so I end up with x plus 1 squared minus 4, because we had the minus 1 minus 3. And this is the completed the square format. So now from here I can tell that this is a plus 1, so my turning point is going to have an x value of minus 1 and minus 4. And now I have my turning point. So I have the turning point, I have my x-intercepts, I have my y-intercepts, and I know it's a happy graph. So now I can just stick everything onto a graph. So let's put this function over here onto the graph. So the minus 3 tells me that my y-intercept is here. And I know that it's going to be a happy graph, so we can get something that looks like that. Now let's put our turning point onto our graph. Our turning point, as we worked out just now, is at minus 1 and minus 4. So here is minus 1 and here is minus 4. So we have a turning point over here. Now let's put our x-intercepts onto the graph. Our x-intercepts are at 1 and 3. So here's my 1 and here is my 3. And now I just need to join the dots. So I will get this graph over here. And don't forget to label all your points. So we will end up with this. And we have graphed our function. Now it is possible to not have x-intercepts if we had a graph that goes up this way or something like that. In that case, you can still graph it using the shape, and we can maybe substitute a value of x into the equation to find the value of y and use that as an extra point so that we'll be able to graph the function. I hope you're all now happy with the method that we follow when we want to graph a parabola. If there are any other topics you'd like me to cover in a video, please leave your suggestion in the comment section below. Happy studying, guys.